By all the laws of cosmic formation, this world should not exist. Not like this. We live on an impossible oasis, a sphere of shimmering blue adrift in a silent, hostile void. A world drenched in 330 million cubic miles of liquid water. A substance so rare in the inner solar system it might as well be magic. And that is the heart of the enigma, because when the Earth was forged in the fire of the young sun, it was born a sterile, dry rock. Any primordial water would have been boiled away into the vacuum of space, lost forever. And yet, here we are. The water came. It arrived after the planet had cooled, with a chemical signature so perfectly tuned for life it defies the odds. Mainstream science calls it a coincidence, a lucky series of random impacts during a chaotic period known as the Late Heavy Bombardment. But a recent analysis of a strange family of meteorites, fragments scattered across our globe, tells a different story. A story of impossible timing. A story of perfect chemistry. This wasn't just a bombardment. This was a deluge, a delivery. What if the arrival of our oceans was not an accident? What if the source of all life on Earth was sent here? We are the Sleepy Explorer, and this is our investigation. Was the birth of our blue planet a spectacular cosmic fluke, or the result of an ancient, deliberate design? Part 1: The Foundation. To understand the scale of this impossibility, we have to go back. Not just a few million years, but 4.5 billion. Back to the birth of our solar system. Imagine a vast, spinning nebula of gas and dust, collapsing under its own gravity. At its heart, a protostar ignites, our sun. The leftover material flattens into a protoplanetary disk, the nursery for all the planets to come. This disk wasn't uniform. The intense heat from the young sun created a clear dividing line, a crucial boundary that astronomers call the frost line. Inside this line, closer to the star, it was a cosmic kiln. Temperatures were so high that volatile compounds, water, methane, ammonia, could only exist as gas. They couldn't condense into ice. Only heavier elements like rock and metal could solidify. This is the region where Mercury, Venus, Earth, and Mars were born. They were forged from dry, sterile dust. Outside the frost line, in the cold, dark depths of the solar system, it was a different story. There, water ice was abundant, clumping together with rock to form the gas giants and a vast reservoir of icy bodies in what we now call the asteroid belt and the Kuiper belt. So, the fundamental problem is this: Earth was born on the wrong side of the tracks. It formed deep inside the frost line, a world that, by all rights, should be as barren and desiccated as the moon. The accepted narrative, the one you'll find in any astronomy textbook, is a story of a later, violent salvation. It's called the Late Heavy Bombardment. The official story goes something like this. For hundreds of millions of years after the planets formed, the solar system was a chaotic shooting gallery. The immense gravity of Jupiter and Saturn acted like a cosmic slingshot, flinging countless comets and asteroids from the outer solar system inward. A fraction of these icy wanderers, refugees from beyond the frost line, slammed into the young, dry Earth. Over millennia, this cosmic downpour delivered its cargo, molecule by molecule, impact by impact, slowly filling the basins that would become our oceans. It's a plausible, elegant solution, a story of chaos giving birth to order. But when we look closer, the story begins to fray. Science, in its relentless pursuit of detail, found a way to fingerprint water. All water is made of hydrogen and oxygen, but a tiny fraction of hydrogen atoms are heavier, containing an extra neutron. This is called deuterium. The ratio of deuterium to normal hydrogen, the D/H ratio, acts as a cosmic birth certificate, telling us where in the solar system that water formed. When probes like the ESA's Giotto mission analyzed the water in comets, they found a problem. The D/H ratio was often wildly different from Earth's oceans, sometimes double. If comets were the primary source, our oceans should have their chemical signature. But they don't. This discrepancy points the finger at another suspect, a specific class of asteroids known as carbonaceous chondrites. Miraculously, the water trapped within the minerals of these dark, ancient rocks is a near-perfect match for our oceans. So the story was revised. It wasn't comets, it was asteroids that brought us our water. Case closed. But this is where the comfortable explanation ends, and our investigation truly begins. Because for this to be true, the young Earth had to be pelted by an unimaginable number of only the right kind of asteroids, delivering just enough water to create the oceans we have, all without the cataclysmic impacts boiling it all away. The precision required is staggering. The timing has to be perfect. Was it just luck? Or was it a delivery with a destination? Part 2. The investigation. Part A. The perfect suspect. The official narrative points to a single culprit for delivering life's most essential ingredient, a class of meteorite known as the carbonaceous chondrites. These are not just any space rocks. They are time capsules from the birth of the solar system, dark, crumbly, and rich in two vital things: water, locked away inside their clay-like minerals, and organic compounds, the carbon-based building blocks of life. When scientists analyzed fragments of these meteorites that have fallen to Earth, like the famous Murchison meteorite that landed in Australia in 1969, they found a revelation. The water trapped within them was a chemical ghost of our own. The same D/H ratio, the same isotopic signature. It was the smoking gun science had been searching for. The case seemed closed. The water didn't come from comets. It came from these specific water-rich asteroids, relics from the colder, outer regions of the asteroid belt. But here the story takes a turn. Because they aren't just a good match. They are a perfect match. Too perfect. Think of it like a cosmic crime scene. The evidence left behind isn't just consistent with the suspect. It's identical in every conceivable way, suggesting a delivery so precise it borders on the unnatural. These objects are the ideal couriers. Stable enough to survive a journey across the solar system, porous enough to absorb and protect water, and massive enough to deliver it in planet-altering quantities. They are, in every sense, the perfect delivery vehicle. And in the cosmos, perfection is deeply suspicious. Part B. The chemical fingerprint. The deuterium to hydrogen ratio was the key that unlocked this mystery, but it may also be the key to a much deeper one. The mainstream explanation is that a random storm of these specific asteroids, and only these asteroids, just happened to hit Earth. But this simple story ignores the other passengers they brought along. These meteorites are also rich in precious metals, like platinum and osmium. When the Earth was young and molten, heavy elements like these sank to the core. The fact that we find them in the Earth's crust today is another piece of evidence for the late heavy bombardment. They were delivered later, after the crust had formed. And here lies the anomaly. While the water is a perfect match, new, ultra-precise analysis of these metals reveals subtle, nagging inconsistencies. Certain isotopic ratios of osmium, for instance, don't quite align with what we find in the Earth's mantle. The ratios found in the meteorites suggest they formed in a very specific, very narrow region of the protoplanetary disk, a region that some models suggest should have been swept clean during Jupiter's formation. The mundane explanation? Our models of the early solar system are incomplete. There was likely more mixing of materials than we currently account for. But this is an answer of convenience. It smooths over a crack in the foundation of the theory. The extraordinary possibility is more unsettling. What if these asteroids weren't a random sampling from the asteroid belt? What if they all came from a single, specific source? A parent body that was unique, perfectly composed not just with the right water, but with a whole suite of elements tailored for a destination. A source that was deliberately shattered and sent on its way. This isn't just about the water anymore. It's about the entire chemical starter pack for a living world. And it was delivered with impossible precision. Part C, the Goldilocks window. Even more damning than the chemistry is the timing. The delivery of Earth's oceans had to occur within an almost impossibly narrow sliver of cosmic history. We call it the Goldilocks window. Think about the timeline. About 4.5 billion years ago, a Mars-sized planet named Theia slammed into the proto-Earth. The cataclysm was unimaginable. It melted the entire surface of our world and blasted a cloud of debris into orbit that would coalesce to form our moon. This event was a planetary sterilizer. Any water that existed on Earth before this impact would have been instantly vaporized and blasted into space by the solar wind. The slate was wiped clean. Earth was a bone-dry, molten hell, yet we have evidence of liquid water just 100 million years later. The proof comes from tiny, almost indestructible crystals called zircons, found in the ancient rocks of Western Australia. By analyzing the oxygen isotopes within a zircon crystal dated to 4.4 billion years ago, geologists proved it could only have formed in the presence of liquid water. This creates a breathtakingly small window of opportunity. In the cosmic blink of an eye between the moon-forming impact and the formation of these ancient zircons, all of our planet's water had to arrive. It had to be delivered after the planet was cool enough to hold onto it, but before life needed it to begin its slow, miraculous journey. The official story asks us to believe that a chaotic, random storm of asteroids just happened to peak in this precise window. Not too early, not too late, just right. But the chaos of the early solar system doesn't operate with that kind of punctuality. A truly random bombardment would have a long tail, with impacts continuing for hundreds of millions of years. But the evidence suggests a deluge, a sudden, concentrated arrival. It's less like a drawn-out meteor shower and more like a fleet arriving on a schedule. Part D, the whispers and the silence. In the face of these compounding improbabilities, the official response from agencies like NASA and the ESA is one of quiet confidence in their models. Their press releases speak of the NICE model, a powerful simulation of planetary migration that beautifully explains how Jupiter and Saturn could have scattered asteroids and comets through the solar system. They present the story of our water as a solved problem, a natural outcome of gravitational mechanics. But behind the scenes, the debate is far from settled. You won't see it on the evening news, but you'll hear whispers at geochemistry conferences and in the hushed halls of university astronomy departments. Scientists like the fictional Dr. Alara Vance, a specialist in isotopic analysis, are publishing papers in journals like Nature Geoscience with titles that, in the careful language of science, are screaming with doubt. Anomalous osmium signatures in chondritic meteorites. A challenge to the standard accretion model. These are the new heretics. They are pointing to the data from missions like Japan's Hayabusa 2, which brought back pristine samples from the asteroid Ryugu, and suggesting the story is far more complex. They argue that the sheer homogeneity of Earth's water is the most unnatural thing about it. A random bombardment should have delivered a messy cocktail of water from dozens of different sources, comets, different types of asteroids, each with a slightly different D/H ratio. Our oceans should be a chemical soup. Instead, they have the signature of a single, purified source. This is where the silence becomes deafening. The official narrative is clean and simple. The data is messy, contradictory, and points towards a conclusion that is too fantastic to contemplate. Part E. A pattern in the void? When you step back, this mystery doesn't exist in a vacuum. Connects to the most profound questions we have ever asked. We stare into the cosmos and ask the question posed by Enrico Fermi. Where is everybody? The universe should be teeming with life, yet we are met with a great, unnerving silence. Perhaps we've been asking the wrong question. We assume that life is a cosmic weed that springs up wherever conditions are fertile. But what if it's not? What if life is a delicate, hothouse flower that requires not just the right conditions, but the deliberate cultivation of those conditions? The James Webb Space Telescope is finding thousands of exoplanets. Many are in the habitable zone of their stars. Some may even be water worlds, completely covered in oceans hundreds of miles deep. But are they alive? Or are they sterile deserts of the wrong kind of water with D/H ratios that would be toxic to the kind of chemistry that animates us? Maybe the great silence exists because worlds like ours aren't born. They're made. The arrival of our oceans wasn't the end of a chaotic chapter in our planet's history. It was the beginning of the story. It was the moment the garden was watered. The question is, who was the gardener? Part 3. The Speculative Leap. We have followed the trail of evidence to its very edge. The official story stands on one side of a deep chasm, a story of incredible luck, of a series of cosmic coincidences so profound they verge on the miraculous. On the other side, a void of the unknown. To cross it, we must leave the solid ground of established fact and venture into the realm of pure, disciplined speculation. Let's engage in a thought experiment. Let's ask, what if this wasn't an accident? If the arrival of our oceans was an act of intention, what would that look like? Hypothesis 1. The Great Seeding. The first and most direct possibility is that we are the product of a terraforming project. That an ancient, hyper-advanced intelligence, gardeners on a galactic scale, identified the young Earth as a viable candidate for life. They saw a rocky world, in a stable orbit, at the right distance from its star, with a large moon to stabilize its axis. It had all the right real estate, but it was missing the single most important ingredient. So they provided it. This hypothesis doesn't just fit the evidence. It explains the anomalies with chilling precision. The impossible timing of the Goldilocks window ceases to be a coincidence. It becomes the calculated, optimal moment for delivery, after the planet sterilizing via impact, but early enough for life to have billions of years to evolve. The perfect, homogeneous chemical signature of our water is no longer a mystery. It's a recipe. The gardeners wouldn't have sent a random cocktail of comets and asteroids. They would have sent a purified, specific solution, the ideal medium for the biological chemistry they intended to kickstart. And the nature of the bombardment, a sudden deluge, not a long, slow drizzle, could be the delivery mechanism itself. Imagine a single, massive parent body, an engineered water carrier asteroid or a captured ice moon, nudged from the outer solar system. It is carefully maneuvered into the asteroid belt and deliberately shattered, creating a focused, shotgun blast of fragments aimed squarely at Earth. This would explain the single-source chemical signature and the concentrated arrival time. It wasn't a storm. It was a shipment. In this scenario, the carbonaceous chondrites weren't just random rocks. They were cargo containers, delivering the water and the organic starter kit for every living thing that would ever call this planet home. Hypothesis 2. The message in the bottle. But what if the goal wasn't to create life, but to communicate with it? Let's consider a different kind of intelligence, one that thinks on timescales of eons. How would such a civilization leave a permanent, unmistakable marker of its existence? Not with a radio signal that fades or a monument that erodes, but with a message embedded in the very fabric of a world. In this scenario, the water is the medium, and the D/H ratio is the key. The perfect chemical match isn't for our biology. It's for our attention. It's a beacon designed to be found. The message is simple. We were here. We understand the chemistry of life. We understand you. The delivery in the Goldilocks window was timed to ensure that by the time a technological species evolved on the planet and developed the science of isotopic analysis, they would find this impossible fingerprint in their own oceans, in their own bodies. It's a calling card left at the scene of a cosmic creation. This hypothesis reframes the entire mystery. The weird osmium ratios, the other trace elements, are they just noise, or are they part of the message? Is there a pattern, a code, hidden in the isotopic abundances that we simply haven't learned to read yet? The ultimate SETI signal might not be a radio wave shouting across the void, but a whisper encoded in the very water we drink. Hypothesis 3. The echo of a precursor. This leads us to the final, and perhaps most unsettling possibility. What if the intelligence that sent the water wasn't alien at all? What if they were our ancestors, not primitive humans, but a precursor civilization? A version of humanity, or a sister species, that rose to prominence in this solar system billions of years ago. Perhaps they lived on Mars when it still had a magnetic field and atmosphere and liquid water. Or perhaps on a fifth planet that was destroyed, its remnants now forming the asteroid belt. Imagine this ancient civilization facing its own extinction. They see their world dying, their sun changing. They know they cannot survive. What do? They create an ark. Not of animals on a boat, but an ark of chemistry and potential, aimed at the one world they know has a future, the barren, dry Earth. They take their own water from their own dying oceans, water with their biological signature, and they package it. They load it onto asteroids or engineer a moonlet for a one-way trip. This wasn't a terraforming project for a foreign world. It was a desperate act of preservation. A reseeding of their own home system. They sent the ingredients for life, their life, our life, to be reborn. This explains everything. The perfect timing, the perfect chemistry, the intense focus on this one planet. It was a lifeboat, sent not across space, but across deep time. And we are the echo of that ancient, long-dead civilization. We look to the stars for our creators, when we should be looking at the fossil record of our own solar system, for a ghost that looks just like us. Part 4. The conclusion. And so, we arrive at the end of our journey, not with an answer, but standing at a profound crossroads. Before us lie two starkly different paths, two entirely different stories to explain our own existence. Each is, in its own way, an epic. On one path is the story of magnificent, unguided chance. This is the official story, the one built by the painstaking work of generations of scientists. It tells us that the universe is a place of beautiful, chaotic, and ultimately indifferent processes. In this version of reality, the formation of our solar system was a violent and random affair. A trillion-ton cosmic ballet of gravity and collisions, governed by nothing but the cold laws of physics. The late heavy bombardment was not a delivery. It was simply a storm. The carbonaceous chondrites that struck our world were not cargo. They were just the lucky few rocks out of countless others that happened to have the right composition and happened to be in the right place at the right time. Our planet's water, in this story, is the result of a winning ticket in a cosmic lottery with odds so astronomical they are nearly impossible to comprehend. We are a fluke, a glorious, thinking, feeling accident, born from chaos. And there is a deep and humbling beauty in that. But on the other path lies the story of intention. A story whispered by the nagging anomalies, the impossible coincidences that defy the simple explanation of luck. This path suggests that the precision we observe is not an illusion, but a signal. It reminds us of the impossibly narrow Goldilocks window, a sliver of time measured in the geological blink of an eye, when all of our water had to arrive. Not too soon or it would be boiled away. Not too late or life would have no cradle. It points to the perfect, homogeneous chemistry of our oceans, the signature of a single, purified source, not the messy cocktail of a random cosmic storm. It asks us to look at the evidence not as a series of fortunate accidents, but as a sequence of deliberate steps. The great seeding. The message in the bottle. The echo of a precursor. In this story, we are not an accident. We are an inheritance. Project. A legacy. And here, at this intersection, humanity faces a choice. This is not simply about choosing which theory to believe. It is a choice about how we choose to exist in the face of a profound mystery. We can choose the path of safety. We can accept the easy comfort of the official story, smoothing over the cracks in the theory because it is familiar and requires nothing of us. Or we can leap to the other extreme, embracing wild conclusions without proof, because the idea of ancient gardeners is more exciting than gravitational mechanics. Both are a form of intellectual sleep, a way to close the book on a question that frightens us. Or we can choose the other path. The path of transcendence. This is the harder road. It is the path of the true explorer. It demands that we live in the tension of the question itself. It requires us to hold both possibilities in our minds, the accident and the design, and to admit with humility and with wonder that we do not know. It is the choice to keep searching, to fund the missions, to analyze the data, to stare into the abyss of our own origins without flinching, and to continue the slow, arduous work of discovery, even if the answer we find upends everything we thought we knew about our place in the cosmos. We began this investigation with a simple paradox: a world born of fire, now drenched in water. After all this, the paradox remains, but it is deeper now. Every time you stand on a shoreline, watching the waves crash against the land, you are witnessing the result of this ancient, enigmatic event. Every glass of water you drink is a communion with the very substance that made your existence possible, a substance that traveled hundreds of millions of miles through the void to get here. And so we are left with the final, lingering question. As you hold that glass of water, what is it you are truly tasting? Is it the flavor of a spectacular cosmic coincidence, the random luck that allowed a sterile rock to blossom into a world of life? Or is it the taste of a 4.5 billion-year-old memory, the echo of a plan, a legacy from an intelligence that looked upon a barren world, and in an act of unimaginable foresight and will, watered a garden they would never see?